Okay, I know I promised you 10.2 coming soon, but no, I was wrong. I forgot about something I wanted to do. So let's talk now. We're going to talk about the distance formula. So the distance formula in space is not much different from the distance formula in the plane. It's just an extra dimension. So if we are given 2 points in space, let's say x1, y1, z1, and x2, y2, z2. Okay, the distance between them is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. See, you guys thought that I was being a little bit exaggerated writing that square root out so long, but see, I needed all of it. Okay, so yeah, that's the distance formula. Not much different. Okay, you don't need to worry about which one comes first. It's just going to be the distance between them. Okay, nothing really too crazy. So we are going to talk about projections. So what's a projection? Okay, projection, well, it's basically if you have like a, for lack of a better word, subspace, which I haven't defined that, it's going to be the closest point on the subspace. So what do I mean by that? So let's just do some examples and you'll see. So let's find the projection of 2, 3, 5 onto the xy plane. Okay, so I'm going to use my standard XYZ as XYZ like that. It does satisfy the right-hand rule. Okay. All right. So okay, 2, 3, 5. That's this point here. Okay, that's 2, 3, 5 right there. Okay. Now, on the XY plane, so the projection onto the XY plane is just simply this point down here. Okay, so that's the projection of 2, 3, 5 onto the XY plane. Okay, this point here, which would be what? That would be 0, 3, 5. That's the projection onto the YZ plane. Should have just copied that earlier. And then change this to YZ. Okay, and you know what's coming next? This point here, that's going to be or that is 2, 0, 5. That's the projection of the point onto the xz plane. Okay, now that's not it all. We could also have, for example, this point here. Okay, that point is 0, 3, 0, and that's the projection of the point onto the y-axis. And as you might guess, this point here, which is 2, 0, 0, that's going to be the projection of the point onto the x-axis. Okay, and may as well finish it with 0, 0, 5. But I have nowhere to put what it is, so you're just going to have to do that for yourselves, okay? All right, so let's find the distance okay, from 2, 3, 5 to, first, its projection onto the xy axis, and then its projection onto the y-axis. Okay, so first, the projection onto the xy axis. That one's pretty easy. It's just the distance from 2, 3, 5 to 2, 3, 0. That's just going to be this vertical distance of 5. Don't have to do much. Now, onto the y-axis, it's going to be the distance from this point to this point. So it's going to be down 5 over 2. So the square root of 5 squared plus 2 squared. Which is the square root of 29. Okay? All right. All right. That's it for the distance formula here. I'll come back. One more problem. This is or actually 2 more problems. We're going to talk about spheres next. Okay? All right. See you in the next video.